Today, another theorem. This is the mean value theorem. So technically it's the mean value theorem for derivatives because there's another mean value theorem for integrals. But usually when people say the mean value theorem, they're going to mean what we're about to talk about. So here's a question that should remind you of a question we did in AP Classroom as a free response question. It says, find the point in the interval 0 to 2 where the instantaneous rate of change of the function f of x equals x cubed is equal to the average rate of change. So I would recommend you pause and try that. And as you're doing it, you might also think about this question. Does every function interval have such a point, or do some not? All right, so think about that and try to answer this. All right, so let's have a look at what we're talking about here. So I think I can look at a picture. So here's y equals x cubed. Now I've zoomed in, so of course we can zoom out and that's what x cubed looks like. But I've zoomed in so that I can really just see the interval from 0 to 2. Now somewhere in here, the average rate of change means the slope of the line connecting the point 0, 0 to the point 2, 8. And the instantaneous rate of change means the slope of the tangent at any given point. So you can see that, for example, up here, the tangent is going to be steep. Down here, the tangent is going to be shallow. Somewhere, the tangent is going to be exactly parallel to that average rate of change. So let's think about what this means, where the instantaneous rate of change. So, and by the way, when they asked this in the AP exam, this is what they were thinking of. You didn't need to know the intermediate value theorem to answer the question, but this is what it was sort of pointing to. The instantaneous rate of change is equal to the average rate of change. Well, what is the instantaneous? Well, let's even just write like that to the beginning. F instantaneous equal to F average. How do I write the instantaneous rate of change? It's F prime of some point, and let's call it C. Okay, some point C in there is equal to the average rate of change, which we know is F of B minus F of A over B minus A. All right, well, I know that F prime of X is 3x squared, so F prime of C is going to be 3C squared, and that needs to be equal to, well, let's see, B and A are right here. This is A and this is B. All right, so that means A is 0, F of A is 0 cubed, which is also 0. B is 2, so that means that F of B is 2 cubed, which is 8. All right, so that means for this slopey fraction right here, I can write 8 minus 0, and for my denominator, I can write 2 minus 0. Now, of course, by the way, there are much simpler ways to get the slope over this interval is 4. If you just look at the graph and think about the graph, you can see that you're really going from the point 0, 0 to the point 2, 8. The slope is 4. So you don't have to write all that out for that particular part. However, as usual, we think about how am I going to get partial credit in case I make a mistake. That's why we write out every step, even if it might be obvious. So C squared is 4/3, and C equals plus or minus square root of 4/3. And if you want, you could say, okay, that's plus or minus 2 square root 3 over 3. Now, there are two values here, all right? C equals 2 square root 3 over 3, and C equals negative 2 square root 3 over 3. I'm going to reject one of them as a solution. Which one am I going to reject? I'm going to reject the negative one. Why? Because C can't be negative, because you can't have a negative answer. No, because the negative number is not in this interval. If the interval were negative 2 to 0, then I would keep the negative 1 and throw away the positive 1. I need a solution that is in that interval. So I'm going to note that negative 2 square root 3 over 3 is not in the interval 0, 2. So when you're going to exclude a value, you usually need to state a reason why. So we're being, very specific about why things happen in this class. All right, so RC is 2 square root 3 over 3. All right, well, so what? What does that look like? So once you know that the value of C is 2 square root 3 over 3, then it's easy enough to get the equation of the tangent at this point. I'm going to spare you that. I already worked it out. It's right here. I didn't even bother to simplify the square roots. The square root of 4/3 cubed is just f of a, what we usually call f of a. It's the y2. And there's our tangent line, okay, right? This is the tangent line there. Now, if I make the equation of the line from the point 0, 0 to the point 2, 8, all right? That's from the beginning to the end of this interval. That line is going to be y equals 4x. So let's turn that on. All right? So see how those two lines are parallel? So this line is usually called the secant line because it touches the graph at 2 points. And this one's called the tangent line. So the secant and the tangent are parallel when x equals 2 square root 3 over 3. And that secant line is drawn over that interval 0 to 2. So basically you can think of like, here's 0 to 2. And I just look at where the function, I don't know why I want to balance this pen here. I just really want to. And it doesn't want to. From 0 to 2, I just look at the beginning of the graph, the end of the graph, and draw that line. That's the secant line. All right? So that secant line is the average rate of change over the interval 0 to 2. The tangent is the instantaneous rate of change from 0 to 2. And you can see if I did a tangent line up here, that tangent would not be parallel to this secant line. All right, so that's about finding a tangent line that is parallel to a secant line, which is the same as saying finding where the instantaneous rate is equal to the average rate. And our next question is there always a point like that? In this case, by the way, I can also find the second one over here, and that's what the AP classroom question was. Like, we could find another tangent over here that's also parallel to this line, but it's not in this interval, right? It's in the interval -2 to 2. So if it's a -2 to 2, there would be 2 points where the instantaneous rate of change would be equal. In fact, it would be these 2 points. But this question only asks 0 to 2, so I only care about this point here. All right, so now the question is there always a point like that? Is there always a point where the instantaneous rate is equal to the average rate of change? Probably not, or I wouldn't be asking the question. So we'll look at some examples next.